steel adds weight. So range anxiety, everything we can be addressed if we achieve lightweighting. And of course, there are a lot of advantages of aluminum extrusion. I need not tell you, you are the expert. But this skateboard chassis can we develop with good engineering is the challenge for the next gen EV, I believe. So there are so many work is happening now. For example, an aluminium we can do up to 30 to 40% weight saving, and this is Novelis is a one company they have demonstrated wherein they have also used aluminium extrusion apart from the other heat exchangers and so on for torsional rigidity and shear transfer. So the larger the battery, the more the aluminium. So today the bus electric vehicle bus is 2% penetration. By 2030, it is expected that it will go up to 30 percentage. That is one of the report latest given by Mr. Randhir Singh, who was the former Niti Aayog advisor. So buses, we can see a huge penetration of EV happening. So who has used aluminum extrusion? So we cannot forget Tesla. So Tesla, they have used in Model X for their chassis. So mainly small number of vehicles, aluminum extrusion it becomes a good option. So rapid iteration and lower tooling cost was the advantage, and they have used it and in mainly in Model X and VS. Model 3 and Y they have not used it because the number of vehicles were higher. And lean manufacturing is possible with aluminum extrusion, and with multifunction fasteners, they have achieved almost 10% weight reduction, which led to 14% increase in the entire vehicle range. So that kind of uh, feedback we are getting by achieving lightweighting. And of course, it is just not the battery pack. So there are two areas. Battery pack for structures, wherein we can see a lot of aluminum extrusion playing an important role. And then, of course, the thermal management. As I told you, batteries, they display different characteristics. And the thermal is very bad characteristic. If we go beyond certain range, it is a hazard issue. And earlier, I was working with ARAI. So there, ARAI, we do crash testing. Earlier, it was a frontal crash, is the most critical one in ICE vehicle. After EV coming into picture, there was a side pole crash. So side pole crash, batteries get crushed from the B pillar. So the extrusion plays an important role. The entire chassis plays an important role in having a safety. And now we have also India has gone for NCAP. So with this, we also have to protect its thermal behavior. So I think this is from the few sources from the open source, but Tesla has used this kind of microchannel extrusions to give a good cooling effect. So mainly beyond two-wheeler and three-wheeler, all four-wheeler, everyone uses liquid cooling. So here we see the kind of they call lasagna noodles kind of nickname, basically microchannel extrusions. Here also battery thermal management, I feel a very good potential for aluminum extrusions. So apart from India, there are so many industries like Audi, BYD. They have implemented this kind of battery packs wherein aluminum extrusions have played an important role in achieving both the structural and the functional performance. Not only the packs, even this is blade battery. So blade battery is directly a very long battery. They have these are the cells. In the cells itself, aluminum is used. So the entire the shape of the battery is changing drastically. So huge opportunity even in cell manufacturing. Now Ola and Exide all are going to launch their own cells. So in cell manufacturing also we can see how extrusion can play a big role in making a very strong cells. Well, I spoke about thermal management and battery packs for four-wheeler. What about the present market? So if we see, this is I think last month data, the highest sold is two-wheeler, somewhere around 1 lakh rupees, 1 lakh numbers. Then it is the e-rickshaw and the car. So basically two-wheeler and three-wheeler dominates the EV industry today. Cars are like hardly 2,000 or 3,000. And even in two-wheeler, you can see few names, TVS Motor and so on. This is the numbers. Here we can understand that two-wheeler, three-wheeler are dominating. But the actual picture, if you see, there is one category called less than 25 kilometer per hour. There is no registration required. There is a 250 watt motor category. That is a very big market. Huge number of players are there, as per Niti Aayog report, earlier there were like 10, 12 OEMs, two-wheeler. Today we have 300 OEMs in two-wheeler industry and three-wheeler industry, only for EVs. And that is a very big market. And this is the latest news. Now government is planning to do crash regulation for e-rickshaw, trucks. So slowly and steadily, only the good players will stand in the market, and those players who need not do registration, they will slowly fade away. At that point of time, good engineering products are required. And I feel in their lightweighting and performance improvement, cell to chassis, cooling, will help in developing a good product and a long-lasting EV with a good safety. So that is so two-wheeler, three-wheeler also we can try good products, battery packs from extruded aluminum. Not just for the bigger players, but also for the smaller players who want to enter into registered category. So this is the target customer. As I told you, 300 plus OEMs, two-wheeler and three-wheeler EVs are there. But there are few, so many other applications. I'm not going to talk, but I hope you got the crux of it. Of course, there are so many alloys. 6 series, 7 series is better, but 7 series is costly. So I think we should go with 6 series. So as I told you about the side pole crash, the car side crash, and there if you see, it should be aluminum can absorb energy, but also it would be strong. So we need a structure which can crumple at the outer and which can stay strong in the inner. So that kind of extrusion will help in protecting the cell to chassis battery pack. So already there is a company called Constellium. They are working a lot on 6 and 4 series aluminum alloy for this kind of application. So of course, I understand extrusion also has a lot of challenges. One challenge is maybe with respect to joining. So people are moving from extrusion to casting, giga casting. Tesla has done, Honda, and even Rivian. They have moved in generation one. They have used extrusion, and now they have moved to casting. So how, as an industry, you can develop a product, an extrusion product, which can be leak proof, which could have better joining technology, so that we can penetrate the EV market, is something as an industry we should all think about, so that we can meet the casting functional properties. So yeah, my last slide is on hydrogen. Since we are also working on hydrogen storage, I thought maybe I will just add one slide on hydrogen, what we are doing. So it is a type 4 hydrogen storage cylinder. So we are making non-metal cylinders, high pressure. Metal cannot work. Similarly for aluminum, this is carbon fiber composite, lightweight. Earlier, you must have seen this kind of vehicle with metal cylinders, what city gas distribution. They use steel structure. So this steel structure is required for steel cylinder. Now when non-metal cylinders are coming, like the company what we are making, the inertia will be less. So here, city gas distribution or oil and manufacturing company, they are transporting gas in a very inefficient way. How to reduce the weight is something, a challenge we are addressing. One way is of course the non-metal cylinder, but also the extrusion. So aluminum extrusion for cascades could be a potential, and of course in hydrogen, non-metal cylinders is going to rule. So there, aluminum extrusion chassis could be one big area where I see a good potential in near future. So I told you inefficiency. So 6,000 kg weight is required to transport 650 kg CNG. That is the inefficiency today we are observing. This structure cannot be changed. These are metal cylinder. But when we go to non-metal cylinders, which is there in the right hand side, still, these are the photograph, and you can see steel is used. Here we can see good potential of aluminum extrusions. So this is my last slide. I just wanted to ask you this question. You must be knowing a lot of engineering, mechanical engineering, electronics engineering, student study, civil engineering. Can someone tell me why the name civil engineering has come to that particular branch? Any idea? Why civil engineering? Why not construction engineering? Why not cement engineering? Okay. So basically, when the British were there, they started engineering. So there are only two engineering disciplines. One was military engineering and one was civil engineering. So military engineering, they work on defense related projects, defense related. Rest everything apart from military, it was only civil purpose. So civil engineering was there. Only two branches were there. That's how the word civil engineering stayed till today. So it is not that today we are talking about collaboration with different engineering disciplines. This was happening even 100 years back also. All the engineering degrees are working together. Now when we want to come to EV industry or hydrogen, we need to really understand the electrochemistry, the battery, and then develop a solution. So collaboration is really important, and the kind of earlier we were working with only one engineering degree. I think we should also work for developing new products in EV market. So so summary, of course, collaboration is the key, because I hope you understood the numbers are less, but the impact is big. So nobody will come to an aluminum extruder and say that this is the design and this is the MOQ. That is not going to happen with respect to EV. We have to develop a complete solution as an industry. So collaboration is the key, and then only we can overcome the disadvantages and of course the cost advantage. So this is me. I am also open for any collaboration. That's it. Thank you so much.
Thank you very much, Dr. Babu, for the insightful presentation. Now, before we move on to our next session, may I, just open the floor for any question. If anybody has any question from our speakers.
Okay.
Hello.
Hello. My question is to the Srinivas sir. Sir, in your presentation, you have mentioned 3 series and 6 series alloys. Both alloys are most, it can be used for the automotive applications. So can you little bit elaborate on which one is more, in which case we had to choose 3 series, or which case we have to choose 6 series?
So it depends on the application. I would say that if you ask me as a broad off the head numbers, if I have to give you 3 series and 6 series are equally distributed,
Okay.
right? There are areas where strength is very important. So there we are getting into more 6 series.
Hmm.
Sorry, 3 series. 6 series we are using where some machinability or some things have to be done, or some kind of brazing and welding have to be done. We're using 6 series. Having said that, it is not just 3 series. We have, for example, we're using maybe 15 different
Hmm.
alloys of 3 series itself,
Hmm.
where we have modified the elements within the 3 series for different usages, at times for strength, at times for long life, at many a times for better workability.
Okay, sir. Thank you.
Are there any other questions for the speaker? Well, okay. So we would like to now close the session, and before we move on to the next session, I would like to invite Mr. Naveen Mittalji from Craft, an honorable member of LMI, to kindly felicitate our distinguished speakers with a small token of a small token of thanks. May I request Mr. Mittal to please be on stage? Please give them a big round of applause. So please come in the middle to take a photo. Thank you very much, Mr. Srinivas, for sparing time for this presentation and sharing your valuable insights with us. Thank you very much for being a part of Alumex India conference. Thank you very much, Dr. Babu, for your lovely presentation. Thank you very much for your time. Okay, well, now we move on to the, before we move on to the next session, just give us a 5 minutes break. We would just like to clear up the head table so that the presentation is more visible. And we have members from Extrutech Group, Germany, and also from Aluminium Stewardship Initiative. So two members are going to join virtually. So just allow us some time to, help them join virtually. Thank you so much. Thank you, ladies and gentlemen, for bearing with us. We have our next session on sustainability and circular economy. And I have Mr. Jan Gunter, Head Sales and Business Development, Extrutech Group, Germany, to give us a talk and a presentation on energy efficiency in aluminum extrusion with electrically heated high-speed convection ovens combined with an inline induction heater. Mr. Gunter, please, on the stage. Thank you.
Yes, thank you very much. Yeah, thank you very much for the introduction. It started pretty busy today, the exhibition, so I'm really happy to be here. I was introduced, my name is Jan Günther, coming from company Extrutech out of Germany. And today we're going to cover the topic of the electrical high-speed convection oven combined with inline induction furnace. This new technology developed by us will flatten the path to a CO2 neutral, or the possibility to have a CO2 neutral extrusion. Before we come to the technology, a short introduction of the Extrakt Group. We are founded in 2005 in Germany. All our activities are in Germany. We have development, engineering, we have the manufacturing in Germany. So to guarantee the highest possible quality, all comes from one source, from us. We also have 2 locations in the United States and about 100 permanent employees, which generate revenue of about 50 million euros per year. Our product range is mainly heat transfer engineering for extrusion and foundry business for every metal. So that means we're having, from the heating side, we're having induction heaters, resistant heaters, what we will see today, and we're having gas heaters and all peripheral equipment for before and after the extrusion press. So now, as a general introduction, I will introduce several well-known heating systems in the market, and we're coming to the newer heating systems. So the left side we begin with a well-known heating system. It's a gas-fired heating system. We use gas, burn it, and then we heat up logs or billets. This is a well-proven concept. I'm sure everybody knows about this concept. New heated generations, they also have a really good thermal efficiency, as you can see here, up to 65%, just the heater itself. For sure, now the topic covering, we need to remove the CO2 from the extrusion plants, so gas is not an option. One step ahead, we have induction furnaces, also well known in the market. Induction furnaces use electricity. They have a really high quality in heating, so they have a really precise taper heating. When we speak about taper heating, we mean different temperature profiles to the billet. So that means beginning of the billet, the head has a different temperature than the foot. This gives you many advantages for the extrusion process. So we can generate an isothermal extrusion. That means the extrusion coming out of the press has at every stage of the press process the same temperature. And it also, this is really important for you, we can increase the press speed dramatically with this induction heater. Then we have, on the right side, we have a combination of 2 heating systems. This combination is for base heating. We use gas heaters. And then we have a manipulating system and use induction furnaces for taper heating. This gives us the advantages. We can, in the most countries, gas is cheaper than electricity. So we can put in the most energy as a base heating with a gas heater. And then we use the induction furnace for taper heating. So for have the precise heating. This is the offline version. We as Extrutech have a patent we developed back in 2014, developed a combination of that inline. What you see here, we start as a base heating also with a gas heater, and then we have a directly attached induction furnace. So that gives you the advantages of both heating systems, but inline. So you don't need a handling system. This will save space, and for sure this will save cost. Then a new technology there's on the market magnetic heating. Magnetic heating uses permanent magnets. Either billet is rotating or the magnet is rotating. We're not offering magnetic heating because magnetic heating has some really big downsides. You can't measure during the heating cycle, so the heating result will not be reproducible. So for you as a extruder, this gives you not the best quality, and we want to assure the best quality. And now on the right side, we have the newest heating system. This is a resistant heater. So we use electricity with resistant heating. This is the technology I'm introducing today. I will show you in how the technology works. So now the first question, why are we needing a new type of heating system? Yeah, we use it because we want to remove CO2 as much as possible in the heating process and at the same time have the highest possible energy efficiency. So we put these two requirements together and then we use this resistant heater. We could when we're starting at the beginning, we have to make sure the electricity we use also comes from a renewable source. Because if we use coal-fired electricity for sure, then the CO2 emission is really high. So we need renewable source. Then we take the electricity inside the plant, and then we have two ways to go. We could either transform the electricity to hydrogen, to other synthetic heating methods, or we use it directly. With this heater, we use it directly in the resistant heating elements. If we transform it to hydrogen or any other processes, we have a lot of transformation. And transformation, we need also energy for the transformation. So the most efficient way is to use the energy directly. And this heater here, with this heater, we have energy efficiencies of 87%, which is the highest possible in the market, what we supply. This is how the system works. So here, this is the long heater. We heat up billets or logs inside. We have several zones. The number of zones depends on the required throughput. So as more throughput we need, as more zones we have. Every zone has 2.5 meters. And we have for every zone a ventilation on top. The ventilator, you see at the right corner, you see right bottom side, you see the airflow inside this heater. The ventilating will suck the air through the middle and then distribute it over the heating registers to the sides and to the billet. At the upper picture, you see how it works, ventilation and the heating registers. So we heat up the air and contribute it to the log for the heating. The system itself, resistant heater and such kind of heaters, they are well proven. What is the most important part about these heaters is what you see here. This is the distribution of the air to the log. Compared to a gas heater, we have lower temperatures here. So we're just talking about heating temperatures inside this heater, about 750 degrees. Compared to gas is much higher. So the heat transfer to the log is not as good. So we have to make sure we use the whole, so we distribute the air to the whole surface of the log to have the highest possible heat transfer inside the log. And this is done by this slot nozzle system you see here. This was quite a big challenge to develop a system which distributes the perfect air. We put quite some effort into this system. The second stage, I just told you the heat transfer is not so good. Also, to have the highest possible quality of heating, we added an induction heater here to this furnace. So the concept of the inline concept I was telling you before is exactly here, just that we use the resistant heater as a base heating. So we put as much energy inside the log or the billets with the highest energy efficiency. And then we use the induction furnace for taper heating to have the both advantages of both heating types in one system. Now we're coming, the most important part, we're talking about the numbers, the energy we need for the heating process. So you see here, just the resistant heater has an energy efficiency of 87%, which is, like I already told, the highest in the market. In the whole process here, as is calculated with a 10-inch billet, throughput about 7.5 tons. Depends if you have higher or slower requirements, it can vary. This is a standard number. We have 123 kilowatt hours per ton as the base heating, and then we use 21 kilowatt hours for the final taper heating. With this, we come to a total number of 144 kilowatt hours for standard application, which is really, really good. Now, this is not all development and some nice pictures. We have several projects implemented in the market. This is one example. So at the upper part, this black drawing, you see the old line with a customer. We have an old chain magazine, an old gas heater with a shear. What we did, this is the blue colored drawing. We implemented a new chain magazine, this new electrical heater combined with the small one in the middle is an induction furnace, so directly attached induction furnace, and a new hot lock saw. This customer operated this gas heater with LPG gas, so he had to bring in the LPG via trucks. So for the CO2, you can imagine it's even worse than being connected to the gas pipeline. So now with this new installation, this new project, we could completely remove the LPG usage. We just use electricity. We could realize on the same floor space, you see here, I did not change the dimensions. The same floor space, we could now with the new system can generate more throughput. So 4.5 tons is a 8-inch heater here. And the accuracy of the heating is much better because of the induction furnace. So in this better accuracy, the customer, he can also increase the press speed at the same time. So really, really good for our customer. Then at the final stage, we replaced the shear with a hot lock saw. So the customer uses logs, and we cut the log just directly before going into the extrusion press. And the cut is really precise, so you don't have any problems anymore with blisters. So the product quality also improves with this system. And now to the most important part, as we're talking about CO2 reduction here. You see here, the customer can save 920 tons of CO2 emission per year. For sure, he uses renewable energy source to achieve that. And then another great effect, compared to the old gas heater, we could cut the energy consumption of the heating process in half because the new heating system is so efficient. For sure, we comparing here kilowatt hours from gas to kilowatt hours from electricity. It's a great project, and that you believe me that we really did. You see here the pictures of the installation. You see in the middle, this is the resistant heater. Here we start with the chain magazine, and we have the induction furnace. And finally, we go into the hot lock saw, cut the billet, and transport it with a standing transport mechanism to the extrusion press. During this project, and even before, we thought, okay, is there maybe the possibility to again increase the energy efficiency? Can we add something? And then we came up with the following idea. This is a patented system by us. We call it the energy saving unit. What the energy unit does, it is a system before even going into the heater. We take waste heat. Waste heat can occur in your whole production. So we can take it from the cast house cooling, can take it from the air compressors, we can take it from the press hydraulics, so from the cooling of the press hydraulics. Then we take the hot water, put it through a heat exchanger, and then we put it through a heat pump. And then we increase the temperature of the water about 85 degrees. And then we supply the water to the logs or to the billets as a preheating. When we implement this system, will be implemented next year in Australia. When we implement it before this resistant heater, we can save up to 9% additional energy efficiency. And if we put it in front of induction heater, we can save up to 15%, or we can increase the energy efficiency by 15%. So now everybody is asking, why using water? Here I brought you this video. This is how the system works. Okay, sorry, it's unavailable, so I'll tell you how it works. You see here, we just supply water as a preheating. So this is even before going into the actual heating system, we supply it over the logs or over the billets as preheating. Now, always the question is, why using water? I can tell you the heat transfer from water to the metal is 5 times higher than air to metal. So it's really fast heating. So we can heat up, in 3 minutes, we can heat up the complete log, the complete billets to the required temperature of 80, 85 degrees. And this is all done by waste heat. So the energy we're using for that is yeah, without any cost for you, because we just have to hook up the system. Okay, now to the conclusion. This sums pretty much everything up what I just told you. To achieve the goal of CO2 neutral or no CO2 emission in your extrusion plants, first we have to make sure the electricity comes from a renewable source, like here hydro, wind, or even nuclear. Then we have low carbon electricity. Then there are two ways. We're using like a middle product. We're using hydrogen or any other products. So we convert the energy to a middle product and then convert the middle product to the final heating. This is here the right way to go. If we do this, we lose a lot of energy because conversion always needs energy. So our approach is to use the energy directly. We can do it, yeah, like I told you, we're not doing it, but there are suppliers on the market having magnet heaters. We not recommend using magnet heaters, but to be fair here, it is a way to go. We can't recommend it. We recommend either go for the induction heater. Induction heater gives you the most accurate heating. And can even be combined with this energy saving we did. The one we recommend for sure was the one I was explaining today. We recommend the resistant heater in combination with induction heater. There we combine the highest energy efficiency in the base heating with the best possible heating results with the induction furnace. And you can see here the main heating has a energy efficiency of 87%, and we can even increase that while using the waste heat to 92%. So far, this was my presentation. I hope you enjoyed something. I will be here the next 4 days, so if you have special questions, you can ask me now or come to our booth and yeah, ask me everything you want to know. Thank you very much.
Thank you very much, Mr. Gunter. That was a lovely and insightful presentation that you have shared with all of us. Because our next speaker is going to join virtually, so we can take the questions from the floor in case anybody has any question. Okay, I guess the presentation was pretty clear, so that's why it's getting processed, and they might just get in touch with you over the next 3 days. I'm sure you're here till 13.
I'm here till
Oh,
Saturday, so
yes, yes, that's great, that's great. So before you move on from the session, we would like to just give a small vote of thanks. Sorry. So our next message was actually from Dr. Fiona Solomon. She is the Chief Executive Officer of Aluminium Stewardship Initiative and is globally respected sustainability leader with over 25 years of experience in responsible sourcing and corporate accountability across the metal and mineral sector. She was supposed to join us virtually over link, but somehow I guess she got a little busy. So we have a message from her side. Before I invite the next speaker from ASI, Mr. Sharma, Ganga C. Sharma, I would like to first play her message for everyone. Just allow me a minute.
Hello, I'm Fiona Solomon, and I'm the CEO of the Alumex Stewardship Initiative. And it's a pleasure to be able to talk to you today at Alumex India 2025. I'm speaking to you from Melbourne in Australia, and so I'm sorry I didn't have the opportunity to be there with you in person, but I very much appreciated and felt honoured by the opportunity from Alumni to participate and contribute. I am going to be speaking about driving responsible production and sourcing in the global aluminium value chain and speaking about the Aluminium Stewardship Initiatives, or ASI's, work in this space. So first to start about ASI as an organisation. We're a global multi-stakeholder initiative and we're working to drive a sector-wide sustainability transformation for aluminium. We focus on the whole of the supply chain, the whole of the value chain, and within that, as we know, extrusion is a really key sector. But we're working from bauxite mining right through to downstream end-use sectors across a variety of aluminium uses. We're 10 years old this year in 2025. We were incorporated back in 2015, and we are a registered charity. Our prime focus is on standard setting and certification, but we also work beyond certification, as we call it, to try and amplify our impact with broader stakeholders such as communities and Indigenous peoples. Our membership has been growing very steadily over the last 10 years, and we are getting closer to 400 members. And through our certification program, we have more than 500 certified facilities across 63 countries. In India, we have a range of members that are headquartered here, as you can see on the left, and on the right, a selection of some of our extrusion members globally. What we do is to work to promote measurable and continual improvements in the key environmental, social and governance, or ESG, impacts of aluminium. We have a multi-stakeholder governance model, and that underpins the decisions that we make as an organisation. We have a standard setting and certification focus, but beyond that, we are also working to train and build capacity for members, auditors and other stakeholders to implement these better practices. We collaborate through partnerships and with other organisations, including with cross-recognition, to try and make sure that we can leverage what we're building in ASI and make sure that connects in with the huge amount of work that is happening in this space. And we also carry out data and research to measure and evaluate our impacts as an organisation and as a sector and a value chain more broadly. So the certification program that we run is our flagship in many ways, and it has two parts, two standards. The first standard is our performance standard, and it sets out practices for sustainability and human rights principles that can be applied by companies right along the value chain. It sets out what's material, if there are specific things for bauxite miners or for bauxite residue management, for example. But in general, we are looking towards some consistent expectations through that value chain. So that's very much about the practices, what a company does. The chain of custody standard is then taking a link about that performance and creating a link then to the responsible sourcing of products or materials. And it does that by connecting certified suppliers and customers and accounting for material flow. By putting those two standards together, having certification against both, we're looking to provide recognisable assurance for responsible practices and responsible sourcing for the aluminium value chain. The certification process is built for continuous improvement and moving towards compliance. And the assurance process, or the audits, are underpinned by an independent third-party audit that's carried out by accredited audit firms. There's a number of steps to the process. It starts with a self-assessment. Members of ASI, they work out what they want to certify. They initiate what we call a self-assessment in Elemental, which is our online assurance platform. And it's an opportunity to look at where your performance is sitting now relative to the standard and ideally address any gaps before the audit happens. The auditor then comes to site to verify evidence, to interview, to inspect things, and then they document their findings in Elemental. An audit report is submitted to ASI, and we carry out some quality control measures as well, mainly to make sure that we're seeing consistency of effort and rigour globally across the many sectors and places in which these audits are carried out. Once that oversight process is successfully concluded, ASI issues a certification and we update our public information accordingly. If there are any non-conformance areas, these should be addressed by the member through corrective action. And then there are also regular surveillance and recertification type audits, very similar to an ISO process, if that's something that you are familiar with. We aim to support our members in certification and more broadly. We run Elemental, which, as I said, manages those self-assessments, audits and reporting processes. It's a custom-built platform by ASI. We also have Educational, which is our learning platform online, where you can access a range of learning modules. We have regular webinars on key industry topics, usually 45 minutes long. And we also have a help desk and FAQs available, and you can access direct support from our very knowledgeable team. And then connecting with peers is also an opportunity through working groups and similar, and that's a way to share knowledge and further build learning and capacity building. So as we know, and as you know even better than me, I'm sure, extrusion is a really key sector for impact. It feeds into infrastructure, transport and renewable energy type applications. And so becoming part of the global effort to drive positive change in these supply chains is really critical for the broader sustainability transitions that we're trying to make as a world. And as a company, being part of ASI is an opportunity to improve performance and to scale up progress on key ESG issues by doing that collectively, by doing that as a sector as a whole. So with that, I'm going to hand over to Gango, who is going to talk a little bit more about ASI's work. But feel free to get in touch with me if you have any questions or would like to talk further about being part of the ASI community. Thank you very much.
Well, that was a quick message from Dr. Solomon from ASI. We also have Mr. Ganga C. Sharma, Managing Director and CEO, Citizen Verifica Private Limited, and he is also a registered specialist with ASI. Dr. Sharma brings over 28 years of global experience across India, Asia Pacific, China, and EU in the roles in management consulting, corporate sustainability, ESG, and compliance. So, okay. I guess there's some technical glitch. Just allow us a moment. Apologies, ladies and gentlemen. I guess we lost Mr. Sharma somewhere due to technical glitch and he's unable to join. We are unable to connect with him as well. Um, Probably we'll retry and try to connect him again. And whenever he's available, we'll be able to take him on the mic. Our next session, we are quickly moving on to it on policy collaboration and road mapping. And I have two experts from Indian Iron and Steel Sector Skill Council and PwC India. So my first speaker for the session is Mr. Akash Srivastav, who is the technology lead for Indian Iron and Steel Sector Skill Council. I would like to invite Mr. Srivastav on the stage, please.
Good afternoon. Good afternoon, everyone. I am Akash Srivastava from Iron and Steel Sector Skill Council. Actually, for every industry, there is a always demand of a workforce that right skill is required, right person is required, and should have the right area of working. So every time we hire the person with some job description, but once he hired and he go to the workshop, he is not able to deliver deliver your expectations. So here the Iron and Steel Sector Skill Council, which is responsible for the skill development programs under the Ministry of Skill Development and Entrepreneurship. So this Iron and Steel Sector Skill Council is basically we are industry representative for the ministry, which is Ministry of Skill Development and Entrepreneurship. We are also in content development for the curriculum or specifically for the curriculum which is required by the industry need as per your demand. So we just develop those curriculum as per the government guidelines and do the training, assessment and the certifications. In our board members, we have NMDC, we have JSPL, we have Tata, even ALMI is also our board member, and other industries are also there. There are multiple associations, those who are in our board. So in these areas, for these industries, all they are doing the skill development programs that is running equally around the nationally and also the international. This is the constitution of IISSC that we have the PSUs for sale is on board. Medhani is there. Then Vizag and NMDC. We have the Academia for Indian Institute of Foundry. We have the NSDC. We have IIW for the institutions and other areas also. So here the topic is workforce development and skill gap reduction. So here the workforce development doesn't mean only to hire or to fill the job. It is required the right person for the right job. He should have the specific skill to do a particular task because this is the very technical area. No, not everyone can do this particular task in a particular manner. So it is a very specific uh, technical skills are required to deliver this training, deliver the work. So here are the some key parameters that is required for this workforce development. First of all is the skill enhancement and upskilling. If we talk about the upskilling, is maybe the upskilling of the technology, maybe the upskilling of the person who is working in the industry. Also the safety compliances we have to follow while working in the industry. We have also the green skills. What is green skill here? The green skill mention about the area where the people, the worker is able to understand about the how to manage the waste management, gas waste management, or solid waste management, or liquid waste management while working in an industry. And what about the talent pipeline development? The talent pipeline development is we have to hire the person, those who are related to your requirement. If there is a requirement of particular skill, so we are start working on that area from now onward, so that we can have a pool of experts, trainers that can deliver the training. So there is a multiple programs available from the government also, and from the direct industry too. For if I talk about the government initiative, there are multiple programs which comes under the Skill India scheme. In the Skill India scheme, there are multiple programs like Pradhan Mantri Kaushal Vikas Yojana, or you can say there are Deen Dayal Upadhyay scheme, state government scheme, central government schemes that help the industry to train their workforce as per their need. So we are under the Skill India mission, we are doing the reskilling, upskilling, and multi-skilling of the people, so they are able to criteria or match the working of the particular skill. So for doing this particular mapping of the job roles, so we are doing, initially we start with the competency mapping. So we do the competency mapping. At the time of competency mapping, these things are required like the assessment tool, training development, performance management, career development, and the identification of the job role. Basically, the job role identification is a major area which is required for the mapping, to map the competency. Once the job role description is clear to the participant or the candidate, so he is able to, industry is very much comfortable to map those job roles and able to deliver the things. So these are the benefits that are come under the after the competency mapping. First of all, they improve the hiring, then enhance performance, targeted training, career path, and succession planning. So these are the area where the competency mapping is can be covered, and that the industry can get the benefit after the mapping of this competency. So after the mapping of the competency, then the training is required of the workforce, those who are required reskilling, upskilling, and multi-skilling. So there are multiple training programs are planned, available with the schemes, which can be customized as per the industry needs. We can plan the industry training programs. The duration of the program starts from 12 hours to go to 500 hours or 600 hours. So it depends on the industry what program they want to adopt. Then after the training, once the training is completed, then the assessment is taken care by the Iron and Steel Sector Council. So the training program is conducted by the experts. We have the pool of experts in your particular aluminum extrusion field. We have the retired person from the industry, from the government, from NALCO, Hindalco. Many people are working with us, associated with us. Those who work as a trainer, as an assessor. So there are multiple people are working with Iron and Steel Sector Skill Council for the training and for the assessment further on. So for the after the assessment, the candidate is getting the certificate which is given by the government of India. So he is getting the certification under the MSDE, Ministry of Skill Development and Entrepreneurship. So after the training, after the assessment, the candidate will get the certificate. These are the proposed job roles. It is already working. We are already working on, and within a 15 days or month, we are able to make them alive so that they industry can adopt those curriculums and start the training program as per their need. If you think your demand, your requirement is not mentioned here, so you can approach us and we can develop the curriculum as per your need. And then we can plan the trainings and assessments and certifications. Then there is another scheme from the government of India, that is RPL, that is only for the industry people for large, medium and small industry for all. This is for the working workforce. Those people who are already working, those who are working from last 10, 15 years, 20 years, but they don't have any degree, diploma or any other any education certificate. So they can do the training program under RPL and get the certificate from Government of India. And this certificate is have a validity throughout his life. So this certificate having the validity, having the acceptability not nationally, it also internationally it is acceptable. So once the training get trained, or the worker can get trained in this particular training or this under the RPL program, he can get the certificate which is recognized not only in India, it is also in abroad. Then the last scheme is the NAPS. NAPS is National Apprentice Promotional Scheme, that is also run by the Government of India from under the Ministry of Skill Development and Entrepreneurship. NAPS scheme is basically for the people, it is beneficial for both, for the employer and for the employees also. For the employer, it is beneficial because they can get the apprentice who can he need not to be hired. He can just hire for 1 year or 6-month program, and he just give them the stipend, only the stipend, not the salary, not PF or ESI. Anything is not able. You are not required. But in other areas, once we hire the employee, we have to take care of his PF, ESI, and other things. So in NAP scheme, the duration of the NAP scheme in NAPS is from 6 months to 3 years. So you can hire the candidate under the NAP scheme, and he will deliver the training. He will go the OJT programs. He will do the work in the live in the industries and get the stipend from the industry. So this is the norms. Actually NAP scheme is come under the Act, that is 1961 Act. So under this Act, every industry which are having the employee, maybe the contract worker or the permanent employee, more than 30, then it is mandatory for industry to hire the apprentice. And the strength of the apprentice is minimum 2.5% to 15% maximum of his total strength. So it is mandatory from the Government of India to hire the apprentice under the NAP scheme. This is the benefit. Government is also contributing under the NAP scheme. If you are paying some amount to the apprentice as a stipend, so government is also paying 1,500 rupees to the direct DBT to the apprentice account. So if candidate is getting 10,000 from the industry, and also 1,500 from the government also. So in total he is getting 11,500 in total as a salary, as a stipend. And one more thing, the industry can also use their CSR. So this scheme is also can cover the CSR. So it is not required any other funds or anything to not as a do the proper HR hiring procedure. It is only the NAP scheme. You can directly go to the NAP portal, register your company or register yourself as an individual, and you can choose the industry, or industry can select you as per their requirement. This is the basic criteria for the stipend, which minimum basic criteria that is prescribed by the government. That is for 5 to 9 class it is 5,000 minimum, and for 10th class it is 6,000, for 12th 7,000, and the maximum is for the graduate is for 9,000. This is the minimum criteria that is government has prescribed, and after that, as per the industry requirement, they can increase their wages and plus 1500 rupees contribution from the government of India. So these are the curriculums we are offering in the NAP scheme. If your area is not covered, you can write to us and we can develop those curriculum and you can hire the apprentice under those scheme. Thank you. Thank you so much. Any queries? Question? Thank you. Thank you so much.
Thank you very much, Mr. Shrivastava, for coming here on a very short notice. Mr. Sushim Banerjee was supposed to be here, but he really helped us a lot and agreed at the last moment to do this presentation. Thanks a lot for your effort and time, sir. Just a small token of thanks for sparing this much of time. Next on the dais, I would like to invite Mr. Swapnil Gupta. He is director with PwC India. Mr. Gupta is a director with over 15 years of experience in mining and metal sector. He is a distinguished expert for policy making, market strategy, operational strategy, and business transformation for the sector. He's a mining engineer from IIT BHU and an MBA from IIM Bangalore with a specialization in public policy and management. I would like to invite Mr. Gupta on the stage, please.
Hello. Is it visible for everyone? Thank you. Shall we move ahead? Sure. No problem, otherwise I can use this. Sure. Good afternoon, everyone. I'm Swapnil Gupta. I'm director with PwC. Thanks for the introduction. I'm a mining engineer from BHU and MBA from IIM Bangalore. And from last 15 years, I have been working in this sector as a consultant. I got the privilege to work with almost all the PSUs in the mining and metal sector and a few of the private companies as well. So many of the aluminium companies like Nalco, Balco, Vedanta, Aditya Birla Group, and as well as some global companies like Spera, RSAs. I have been part of some advisory projects while working with them. Very recently, I am working with JNARDC for creating a vision plan for non-ferrous metal circular economy, which includes aluminium as well. So thanks for that privilege and thanks for inviting me for presenting my views on in this August forum. So we all know about the aluminum value chain. When we are talking about aluminum production, we understand it has two sources, the primary as well as secondary, through recycling one, as well as the processes involved melting, alloying, sharing, and when we get into the final aspect of the value chain, when we talk about the maybe the semi-finished product or the final finished product, rolling and reheating. Finally, we get into the extrusion products, and there are a lot of innovations happening even after that, while the aluminum is being consumed by the end-use sector like automotive, vehicles, utensils, or any other. What we can see is in this entire value chain, there are so many points where there are technological advancements going now every now and then. Working with various clients, we can understand these technological advancements are not only happening in terms of improving the efficiency of the processes, but also utilizing AI and generative AI to further reduce the cost of operations and improving the profit margins for the companies. Because aluminum is not only fighting for the space in terms of the industry, but also competing with the different materials, the alloys and the different materials which is coming into the play. When we talk about what is the push towards the aluminum growth, we talk about the smart cities, electric vehicles, and many other implementations into the technology and sustainability space, which are driving the aluminum sector growth. In terms of numbers, if we talk about more than 1.5 lakh crore of investment would be needed in the smart cities mission alone. There would be huge push in terms of infrastructure and construction sector because of the global growth into the population and urbanization of the Indian sector, Indian population. Another push is coming from the government's push towards the electric vehicles, and when we see more than 3,679 crores are being invested in different schemes to promote electric vehicles. And then there is push towards the recyclability, sustainability aspects. So while we are trying to, increase our generation, our consumption of the secondary materials, or we can say the scrap aluminium. In terms of graphics, we as a consultant always love to, present our findings with the numbers. When we see what is the applications of aluminum in different sectors, of course, it's come out as an extrusion is the biggest sector, where almost 34% of the aluminum demand is being generated through, and that finally translated into the construction, automotive, and transport sector. Similarly, FRP, the flat roll product, are the second, which is almost one-third of the demand, and the rest casting is at 23%. Of course, we are talking about the wires, the cables, and other paper and other consumable industry, which are further improving into the demand. But extrusion is a sector where the growth of the demand is the most accentuated. If we see the global market, which is growing at around 5.6% every year and going to reach to around 31.5 billion units by the next 10 years, we can see the aluminum extrusion sector demand is accounting to the largest share, to the 40% of it. In India, which is the fourth largest producer of the aluminum, almost having 10% of the global bauxite reserves, but still we are also focusing into increasing of the consumption into the secondary aluminum. So that's why we are promoting the recyclability of it. Next, if we focus only into the extrusion market, aluminum extrusion market, it itself is a one-third of its size, which is 101 billion by 2034. So the outlook of aluminum extrusion industry would be that to reach about more than 100 billion by 2034. And this drives most of the companies in India like Vedanta, Hindalco, Jindal, Global, Aluminum, and everyone is focusing around improving their capabilities. Further, as we have already spoken about the infrastructure in smart cities as well as EVs, another important emerging sector is about the high quality extruded products with global exports towards the Europe, Southeast Asia and other parts of the world. So that is the main areas which is driving the aluminium extrusion demands. So what are the challenges we see into the aluminum extrusion product? So when the challenges come, then only we can think about what are the R&D spaces where investment would be needed. So when we talk about the challenges, first is the market structure in itself. When we look at the market of aluminum extrusion industry, more than 70% of those are the small or MSME players. Of course, this fragmented market lead to a lot of inefficiencies and lower productivity of it. Second aspect is about the import dependence. We are still largely dependent on the import from China, US and Taiwan for high specific profiles, very specific, lightweight, crash resistant, auto component and others. Then there are regulatory pressure. We can see just in October 2025, the mandatory BIS quality control norms. So all those pressures are also, the small fragmented industry would require time to adjust to the regulatory changes. So those are the, challenges which we see. Another thing is about the decarbonization cost. Currently, we all know that aluminum industry faces most of the its cost is getting into the power or the captive use. So that if we are moving from the coal to any other renewable sources, the cost of decarbonization will also impact the aluminum overall final profitability. And lastly, there is an OEM confidence gap. Any sector to grow requires a lot of support infrastructure. So as we are talking about that most of the MSMEs are driving this sector, of course the reason remains the vulnerability of our OEM suppliers for that. If I talk about the numbers, these low productivity resulted into Indian companies not to compete globally. Then because of the import dependency and we see the geopolitics play over it, we are always dependent and there is always a risk of our supply chains. Then this cost of decarbonization, if I just give you a number, the transition to net zero would require at least 2.2 lakh crore of capex investment. So all these are the roadblocks in our growth projections and our requirement into getting into the global best. Some of the R&D research is going in the sector which we have spoken about in the terms of like improving the effectiveness of our products like alloys. So for example, the researchers are going into energy observing alloys for automotive safeties. Then there are non-heat treatable alloys for crash resistant casting. Then peripheral cross grains, homogenization, anodization and MOA. JNIDC is already having their R&D facilities in all of these 6 areas, and a lot of good work is happening around it. So any of the companies who requires any of the inputs in these of the R&D approaches can approach to JNIDC. What we understand in terms of supporting the India's growth or ascent into R&D space in aluminum extrusion space required 3-pronged strategy. In terms of short-term strategy, we can think about foundation of the R&D enabled quality. So, of course, many of these steps are being supported by government funds as well as Center of Excellence like JNIDC, who promote and fund the sustainable opportunities for new R&D manufacturers. But what we think in the short term, there can be modernized grants. There is a grant like PRISM and others, which can further support to develop the R&D quality parameters in these space. Then other than not only funding, but also to create an incubation system, incubation hub, which will support these MSME researches to get the benefits out of those within a short term of 2 to 3 years. Then there is a medium-term strategy. We already spoken about there are a lot of institutions which are being set up like CMRI and others, which will support these R&D ecosystem in the space. but that need to be driven through the measurable outcomes, like how many MSMEs have started, productions into their R&D pilots, how many, R&D initiatives converted into the pilot systems, and then how many pilot projects can then converted into the final, commercial space. So there are so many areas where, lot of works can be done. And lastly, in the long term, we can tie up with our global, hubs in the western part of the world, in Europe, US, and any other developed economy, where we can sign up the MOUs, and even we can look for the global patents and IP areas where we can improve our working. So, for example, when we are speaking about the Gen AI and others. Talking about PwC, I mean, we have worked with, various global clients in aluminum space as well as other mining and metal space. We work as a management consultant across domains like market strategy, investment, contracting, performance improvement, and implementation. We have our global center of excellence across 8 countries, and India is one of the part of these COEs. Every year we publish a global mine publication, which we call, where we review top 40 mining and metal companies, and we try to see where the mining sector is going by analyzing the financials of the top 40 mining companies. One very recent publication which we have done about Gen AI, applications into the industrial manufacturing space. What we see based on different usage in different processes of sales, planning, R&D, production, support function, we can save up to 10% of the cost in the manufacturing space. And most of that is driven through the sales and marketing aspects of self, as well as demanding to the R&D space. So even 1.7% of the cost saving can happen by just using AI, artificial intelligence, into the R&D space. So that's it. Thanks. This is my profile. If there's any question, I will be more than happy to answer. Thank you.
Thank you very much, Mr. Gupta, for this information-packed and powerful presentation. Do we have any questions from the floor? I guess the presentation was pretty clear. So before you proceed, we would like to just give you a small vote of thanks from our side. Thank you very much. Well, ladies and gentlemen, we would now break for a quick tea, and it's going to be a 20 minutes break. So we are right now at 4:20. So let's be back by 4:40, and then we will start our next session on aluminium alloy in transportation. And we have members from Vedanta Aluminium and also from Automotive Research Association of India, Pune. So please be back on time, 4:40. Yeah, thank you so much.